Alright then, we are here, day one, flight training. We're going out in a Tobago TB10. So today we're gonna hopefully learn a bit about the aircraft, how to take off, how to land, the name of bits. But yeah, it's all exciting. Thank you to David for taking me out, taking time out of his day.
So this is our one.
We're hey. We're hey.
So that's the
wicked.
cockpit. I'm just going to check the paperwork because that's from the engineer. I think you're talking about the carpet.
Carpet here.
When you use a spray can,
Yes.
and you keep your finger on the spray for a long time, what
Yeah.
happens to the can?
Yeah.
When you spray the liquid from the can, it's going from a wide space through a nozzle.
Yes.
So you're pressurizing it and forcing it out through a nozzle. So as the pressurization happens,
Yes.
it's cooling down.
Mhm.
And that's when it goes cold.
Yes.
So now imagine that is a carburettor where
Yes.
you have big wide space and then you have called a venturi, a tube that gets smaller and smaller and smaller to allow the air to get pushed into the carburettor to mix with the fuel.
Yes.
Where because that venturi is reducing the diameter of the space the air is going through,
Yes.
you're pressurizing that air.
Yes.
And in pressurization, it's cooling.
Okay.
Now, you've got clean, dry air.
Yes.
You're never going to get any icing happen in that area.
No.
The water molecules need to hit that venturi to get colder to freeze
Yes.
as they hit that surface. So what happens is, if you enter visible moisture,
Yes.
so cloud,
Yes.
and you're below freezing or close to freezing, that carburettor will be ice cold, the water molecules will hit it, ice will build up within minutes,
Yes.
and you'll block the air entering the carburettor. So the point of carburettor heat is that you're now introducing hot air into the carburettor,
Yes.
which reduces the power you're getting from the fuel because you're mixing hot air into the fuel, but it de-ices the carburettor, which the ice will be coming off and going through the engine.
Okay.
But the aim is never to enter visible moisture below freezing.
Okay.
Now, there's a little bit of a quirk to that, a kick in the arse, because if you've got a very hot, humid day
Yes.
and you're at a certain altitude, you can have exactly the same effect.
Okay, so it's a
Because
change
even though
in
you
temperature.
can't see the moisture,
Yes.
there is moisture in there because the humidity is really high. It could be 85-90% humidity.
Yes.
So you get icing at the visible end of I can see the clouds.
Yes.
The other end is I think it's absolutely lovely, hot day,
Yes.
but you get icing as well.
Okay.
So carburettor heat is your manual consideration of how do I keep that, and we turn it on and off during the flight just to check the engine.
Checking
one
it's
of our
running.
checks.
And it's when you're turning on and off your carb heating, you just look at the change of revs to see that that's
You're
actually
looking at the
kicking
change
in.
revs. Yeah. If you get a noticeable change in revs or difference in the sound of the engine,
Yes.
you know there's ice.
Fine.
Yeah. If there is no change whatsoever,
Yes.
then there's definitely ice,
Okay.
because it means you put the carb heat on and there's no change. So there must be a lot of ice there.
Yes.
If you get a very little change, then you're clear.
Yes.
If you get a very big change, you're iced up. If you get no change, you're definitely iced up. Next due, 19th March 2027, stamped and signed. If this wasn't here, we wouldn't be allowed to use the aircraft because this is what we call release to service.
Yes.
So flying it, it's in service. It's gone in for maintenance, so it's scheduled maintenance. And once it's gone into maintenance, you can't fly it unless maintenance release it to service.
Yes.
So they could have put it back in here and gone, we'll finish that work on Monday.
Yes. And you think it's all okay.
Oh, it's in
You've
there,
got a
yeah,
piece
it's
of
fine.
paper. Now someone
Now
said.
I've got a piece of paper. The black area.
Yeah. Wah!
Jump in. To the side from left to right, You got your fuse board by your knee.
This.
They're all the fuses.
Here.
On it. So if we're flying on autopilot,
Yes.
and the plane starts doing something stupid,
Yes.
and we really can't understand, so we're struggling to fly the plane manually because the motors are trying to control everything.
Yes.
We pull the fuse breaker on there. We just pull it out.
Yes.
Kill the power to the autopilot, and then that means we can fly.
Yeah.
You might be in autopilot mode when you're in some crappy weather.
Yeah.
So it's a bit crappy out there, and you go, you know what, it's really crappy, I'm going to put the autopilot on, I know the plane's going to go where I want it to go because I programmed it, and then suddenly the plane just suddenly goes, hey, and you go, what the, and you're struggling to force it back because the motors that drive the autopilot are taking control.
Yes.
And you go, right, I'll turn the autopilot off, but it still doesn't change anything. You pull the breaker. So that's why it's got an arrow on it, because it's probably the most important one there is.
So where do we turn the autopilot on and off from?
So the autopilot is here.
Yes.
And we've got something called heading mode, nav mode, approach mode, and reverse course. Essentially, when you've got a compass on here.
Yes.
And you'll dial this, it'll be like a compass rose.
Yes.
There'll be a bug that you can rotate around with this dial.
Yes.
And you can set the bug to 280 degrees, 150 degrees, and if you put heading mode, the aeroplane will fly that heading.
So why 250? What's
it could air traffic
degrees?
Control could have said to you, fly heading 180 degrees.
Yes.
So you'll go 180, the plane will automatically turn on to 180, and when it gets there, it straightens up and it will fly 180. You've got to control the altitude.
Yes.
But it's one less thing to worry about, especially if you're doing a 3-hour flight.
Yeah.
You did down to the south of France or somewhere, you just get it on autopilot, and then I just sit there and I put my hand underneath here on my chatting to my mate I'm with or whoever, and I will just be controlling the altitude and movements to maintain 6,000 feet, 7,000 feet, whatever it is we've been given, will literally just be the movements, will just be little movements like that. No difference to you driving on the motorway trying to keep it in lane. I'm flying it manually, so typically it's about there. So I will typically, when I'm flying, if I'm doing a full manual, my 2 fingers, I'll just have 2 fingers on there, and I'll just be making little movements like this, and I might do this as well, which this is the trim wheel, and that just removes. So you could be holding that there, so put your hand on the control and resist my movement. I'm going to push forward. Now you can feel my movement there. Now if you had that for 2 hours, you'd be buggered, your elbow would be buggered. And that could be because the wind is on the elevator, the speed and other bits, but the aircraft just wants to go down and you're just holding it and pulling the back pressure. So what you'll do then is you'll trim this, which is on the rear, and it just changes that pressure, and you go, oh okay, and then
that's
you can
better.
let go and it flies level.
You're within a level.
This is just removing those forces that are just build up depending on how you're flying. Let's start from left to right. You got your key. You got your left and right fuel tank.
Yes, and that's for balancing.
You balance it. I typically do it every 30 minutes. If I'm on full tanks, what I'll do then is I will fly on the main tank for an hour. And then I will switch it every 30 minutes. But if you're doing little flights, typically about halfway there you'll just switch the tanks. If it's half an hour flight, you go halfway. So
you're taking off on a stable load.
We always we taxi. We have to do power checks, but we taxi to the power checks on one tank, and when we do the power checks we switch to the other tank, and that way we prove both fuel tanks are functional. You know, it could be a blocked pipe. We don't want to know. We don't want to know that when we're taking off. So there's the parking brake. That's an altimeter. How does an altimeter work?
So is that telling you what altitude you're at?
It does, but why is there a lead dial there? What's in that window?
So is that the altitude in which you're to climb at a certain speed or drop at a certain speed?
How do we know? How can we derive what altitude we're at?
Only from dial, like what it tells us what.
Because this will tell us whatever we want it to tell. If I want to pretend that I'm at 500 feet.
We've got the altitude from here.
But I can change that as well.
Okay.
So what's changing? That window. When I move the dial.
You move this one here is changing.
And what's that number?
1015 to 1020.
So what do you think that is?
The feet?
Nope.
Okay.
Air pressure.
Fine. So you have different air pressure.
Different every day.
Okay.
Every hour.
Yes.
Air pressure changes depending whether it's a high pressure coming across the country or low pressure.
Yes.
So we know that there is scientifically,
Yes.
in what we call standard atmosphere, 27 hectopascals.
Yes.
There's 27 feet per hectopascal of pressure. So as you're climbing, 27 feet will give you 1 hectopascal.
So that hectopascals
So they're
there?
hectopascals, and they will tell us what they are, where we are. And
Yes.
it changes during the flight. So you'll hear air traffic will say to you, or air traffic information service, they'll say to you the weather, and part of that they'll say to you QNH is 1020, QFE 1017, and the QNH is air pressure at sea level, and QFE is the air-filled air pressure.
Yes.
But the airfield could be at 300 feet above sea level.
Yes.
You know, we're about 50 feet here, I think it's 28 feet or something. But Kembal's 400 feet, Bristol 600 feet. So the pressures are different for the different airfields. And whatever that number is, you plug into here. So at the moment, I know at 0, the QFE is whatever reads there. So there's our frequencies. So there's ATIS is 127480. So I can put in there 127480. And then put that onto
temperature 5, dew point 4, QNH 1021 hectopascal.
what does it say there?
1020 is down there. So we'll set that to 1 set.
So that's on 0. Change it to 0.
Yeah.
And where the little line is,
Yeah.
read off the number. There's a count the dashes.
1017.
Okay, so you think it's 1017. Listen to the radio.
This is Gloucester Airport. ATIS information. Bravo at time 0920. Arrival runway in use 09. Surface wind variable 2 knots, varying between 2.
Listen out for what it says QFE.
And 350 degrees. Visibility 500 meters. Fog. State of sky obscured. Vertical visibility cannot be assessed. Temperature 5. Dew point 4. QNH 1021 hectopascals. QFE 1018 hectopascals.
Okay.
Oh, pretty close.
Low visibility procedures in force.
So that's telling us the wind, what the visibility is, what the cloud base is, and all that kind of stuff. And we need to get that. And they listen.
Read back altimeter setting in use. Advise ATC that you have copied information. Bravo.
Bravo. All right. So I'm going to turn that off so we don't kill the battery.
Yes.
So they've given us information Bravo, and every 30 minutes that'll change to Charlie, Delta, Echo, all the way through the day and start again.
Yes.
So what we do is when we talk to the tower, we call up the tower and say, "Good, Gloucester Tower. Good morning. Golf at Bravo, Kilo, Bravo, Whiskey.
Yeah.
Western Aviation, where we are. Information Bravo 1021 is the QNH. The vicinity of the aerodrome, everybody needs to be on the same setting.
Yes.
Otherwise, there's no separation.
Yes.
And if everyone's on the same setting, and he says to me, Golf Bravo Whiskey, what's your altitude? I'm going to read back what's on here.
Yes.
Then he asks the next pilot that could be coming towards me, and I say I'm at 2,000 feet, and the other guy goes, I'm 2,500 feet, and he will then read back his pressure setting on here. So if I'm asked, I'll go, Golf Bravo Whiskey is at 2,000 feet on 1021. The other guy comes back and goes, I'm at 2,500 feet on 1021. Everybody knows there's 500 feet of separation.
Yes.
If he comes back and goes, I'm at 2,500 feet on 1017, hold on a minute, there's 4 between us.
Yes.
4 times 27, let's go 4 times 30, 3,
Yeah.
6, 9, 12, that's 120 feet. We're closer together
Yes.
than he thinks we are.
Yes.
So that's why it's important that everyone is on that, which is every time we make contact and do things, we talk about the QNH. What's called open FIR.
Yes.
So there's no air traffic control. We can do whatever we frigging like.
Okay.
There are rules, we can't go 500 feet near any man, person, building, man-made object, But as long as we stay above 500 feet and we don't make a nuisance of ourselves, or what the CAA say is, you don't draw attention to yourself,
Yes.
or fly in such a manner that causes concern.
Yes.
You can do what you like. You look out the window, you look for other airplanes, and you adapt.
Yes.
If you're in certain areas, like inside an air traffic zone, which is surrounding an airfield, it's a protected space, or you go to Bristol, and there's a huge segment of Bristol is controlled airspace because they need to get the jets in and out.
Yes.
And it's kind of a motorway.
Yes.
It's like there's motorways running through the sky called
Yes.
airways, and there are off ramps and on ramps to those motorways, and they are called controlled airspace, and they're usually class D. So class A, the airway, and class D is these on and off ramps. And those on and off ramps go to major airports like Birmingham, Bristol, Exeter, London Heathrow, Gatwick, and they've all got their own on and off ramps. And they're controlled by, at the high level, it will be kind of London control, and then you come south and it might be Wessex radar, and then it'll come down again and you'll get Heathrow radar. Gloucester used to have a radar, but they don't anymore. They've just not paid the money to keep maintenance on the radar because it's too expensive.
Okay.
And they made the decision we don't need it. It may come back again, but usually these things, once they get rid of them, they don't. So you talk to whoever you feel is going to give you the best service for the safety of your flight.
Yes.
So it's your responsibility. You don't have to talk to anyone, and if you're in controlled airspace, you do. Outside of controlled airspace, you can do whatever you like. So we got the airspeed.
Yes.
It's called attitude indicator.
Yes.
It tells us where we're going, up, down, left, or right.
Yes.
You know, because that brown is the ground and the blue is the sky.
Yes.
Altimeter or altimeter, whichever way you prefer.
Yes.
These are to do with navigation. Vertical speed.
Yes.
You don't typically want to say anything more or less than 1,000 feet per minute. Any more on something's not right. If you're above 1,000 feet per minute descent, then your airspeed's going to be going crazy.
Yeah.
And you'll be ending up in the kind of the
Are you
amber.
aiming for like a 500 feet? 500 feet?
500 feet. It's a nice sensible. So
And where would it say for 500? If coming down, that's on at 5?
5 or 500 climb. 500
Yes.
descent. This is the comms box. That's like an amplifier.
Yes.
And this is a GPS maps. That's a backup radio to the top one, so we can talk on both of those. This is called a transponder, and they give us a code, and we put that code in, and that code will appear on radar screens. So when we're identified by a radar service or London Information, which is a lower airspace service, they will say to you, squawk 4531.
Yes.
That's what Gloucester would tell you to do. So 4531. So if I turn that on now, I go 4531. I often put that in before I even start up. So when I actually talk to them the first time, I'll say, Gloucester Tower, good morning, Golf Bravo, Kilo Bravo Whiskey, Western Aviation with information Bravo 1021, squawking 4531, request taxi for checks.
Yes.
And they'll go back and go, you've just given me all the information, that's all okay. If you don't, they will then have to give it to you.
Yeah,
And that
save
will
some
take up
time.
radio time.
Yes.
And there's other people want to talk as well. So you're trying to communicate a short amount of space time as possible.
That's understandable.
What I'll do is I will be coming into another airfield, and typically what you'll say is, Shobden information, Golf Bravo, Kilo Bravo Whiskey, request airfield information. And they'll give you the wind direction, the runway in use, and traffic and stuff like that. But if you're 20 miles away and you've got the radio tuned into them, you can hear them telling the other pilots that information.
Yes.
So what I do is I listen to it and I go, okay, so this is the wind, blah blah blah. So I'll call up and say, Shotgun information, Golf Bravo, Kilo Bravo Whiskey, inbound with 100, 15 knots, runway 27 left hand, and circuit is occupied. And they'll come back and just go, Golf Bravo Whiskey, Roger. But you
So you would change that to their setting?
Yeah, you would change that. And when you're landing, depending on your personal style,
Yes.
you will change this to the QFE of the runway.
Yes.
I typically will leave it at QNH unless they specifically give me the QFE, then I'll put the QFE in. When I land, it'll be on 0. If I'm on QNH, it will be maybe 200 feet, 300 feet.
Depending what your difference is,
elevation of the airfield. This little baby here, come on.
Arrival
So
runway
this
in
is
use.
our
09
engine management system.
Yes.
Surface wind variable 2 knots, varying between 250 degrees and
You notice it's all Garmin.
350 degrees.
It's all the same system.
Visibility 500
So this will come on eventually.
Fog.
There we go.
State of sky obscured.
And
Vertical
there's the
visibility cannot
heading
be
bug.
assessed. Temperature
So we can move that round.
3.4.
And what we
QNH
typically do is,
10
whenever we do a
to 1
turn,
hectopascal.
and we go, right, this is where we're going,
10
we can rotate that to the top.
hectopascal.
Yeah.
Because if anything
Airfield
happens,
information. Upon
we can
first
always look
contact
back at it and
with
go,
Gloucester, read back
what
altimeter
heading should we
setting
be
in
on?
use.
Yes.
Because we've bugged
Low
the heading.
visibility procedures
What we can
in
do is
force.
we can just press that and it jumps to the top.
Aerodrome service only
So
available
that's
on
where we're
one
going now.
international
If air traffic
555.
control, so we were flying along now, and air traffic control
Advise
said,
ATC
Golf
that
Bravo
you have
Whiskey,
copied
turn
information.
right,
Charlie.
120.
Yeah.
We then turn that to 120.
So right way to 12,
Gloucester
Yeah.
Airport, ATC
and then wait for us to
Charlie.
sit
You can
into
actually
that,
see the number exactly there.
0.
and that would automatically autopilot take us to there. We would
If it was
turn
automatic,
over,
or we would turn to it.
follow
So
it.
if air traffic control give you a heading, you will always turn that, bug the heading, then turn. Because then you know where to stop the heading,
Yeah.
stop the turn. But that's your compass, and that's using a magnetometer at the end of this wing.
Yes.
Which is like your mobile phone, it knows where you are.
Yes.
We used to use the compass,
Yes.
and that still works, but the compass always lags.
Yeah.
Because as you're turning, it catches up and stuff, whereas this is scientifically accurate.
Yes.
Which is great. This is our engine management, so we've got 4 cylinders, and you get exhaust and you get inlet, cylinder head, and you get exhaust, and the 2 temperatures are shown on here as like a bar chart. Oil temperature, fuel pump. So if I get the fuel pump and turn the fuel pump on, you'll see the fuel pump go up.
This is Gloucester Airport. information.
And that's the number of
Charlie,
PSI.
at time 092.
Do that,
Yeah.
I'll turn it off,
Arrival runway in use.
and
090.
it'll drop down again.
Surface
It's got
wind
a
variable
mechanical
2
fuel
knots,
pump
varying between
connected to the engine,
250
but we have 2.
degrees and
Yeah.
350
Obvious reasons.
degrees.
But we always
Visibility
turn the fuel
500
pump on with the engine off, because we know the
Fog.
electric one's working because we see it.
Yes.
And then we turn the engine on the engine fuel pump, but we always know the electric one's there if we need it.
Yes.
Because we've tested it.
And do we use that at all on takeoff, landing, or do we? Yeah.
Yeah, the most.
Airfield
Yeah,
information.
we
Upon first
use certain
contact with
things
Gloucester, read
during
back
those
altimeter
critical
setting in
phases
use.
of flight,
Yes.
Low
which is
visibility
takeoff and landing.
procedures in force.
Yes.
Aerodrome service only
so
available on 128.555.
that's the engine management system.
Advise ATC that you have
We've
copied
gone through that
information.
system.
Charlie.
These are different navigational
So
ways. the
HD
autopilot.
nav APR rev.
Airport.
Yeah.
What would we use?
Just get the battery off. So if you're just bugging the heading, put
Yes.
that on heading mode.
Yes.
So you turn the autopilot on,
Yeah.
then you go heading, and it will follow the bug.
So we change to 120 degrees, and that will change us to 120 degrees.
120.
Yes.
Nav is if we're doing an approach,
Yes.
where you get much tighter tolerances. You're coming into a runway. The runway's only, I don't know, 50 feet wide, 50 meters wide, whatever the size of the runway, and you want to get on it.
Yeah.
So you don't want the autopilot going, oh yeah, plus or minus a mile, that's fine.
Yeah.
It's not.
You're not in the middle of no.
Nav mode will tighten those tolerances. Approach will then tighten it even further. So what we'll typically do is we will go to nav as we get in the vicinity of the aerodrome and we're flying a procedure.
Yes.
And then once we get onto final approach course, we then put the approach button, and that'll just tighten the tolerances even further.
And are we still controlling our
Altitude.
altitude
Yeah.
on that?
Or height.
Yes.
Height is above the ground and altitude is above sea.
Okay.
The difference, if you hear someone say I'm altitude 2,000 feet, that means they're on the QNH. If they say height 2,000 feet, they're on the QFE,
Yes.
because they're using that. And the only reason why they know their height or altitude is depending whether they're on the sea pressure setting,
Yeah.
QNH, or the land aerodrome setting, which is QFE. But the navigation aids, they transmit Morse code
Yes.
to identify them. So BRI is da-da-da-dit, da-da-da-da-dit. And I know that because I've flown in Bristol for 10 years, And I remember tuning up Bristol and hearing da 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 dip da 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 dip, and if I hear it go beep 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 beep, I go, that's Bristol.
Yeah.
It's, you tune up the frequency, you listen to the Morse code and go, is that Morse code what I expect?
Yeah.
If it isn't, you could have tuned the wrong frequency.
Yeah.
And if you follow that navigation aid, you could end up in the wrong place.
Yeah.
So we have an acronym, TITS.
Yeah.
Tune, identify, test and sensible. So we get onto a navigation aid, we tune it, we identify it with its Morse code, we then test it, so you'll see the arrow will turn when we go onto it, and you go, okay, the arrow's turned towards the navigation aid, but the last check is it sensible? Is it pointing where you thought it was going to point?
Yeah.
Because you could be, you know, flying along and you know Bristol's over there somewhere, and suddenly this thing points in that direction, you go,
Wait a minute. Yeah.
alright, I've fucked something up.
Yeah.
So these are all the power switches. So that's the fuel pump. That is the turn coordinator, which is this. It's electric driven.
Yes.
It tells you your rate of turn.
Yes.
There's the beacon on the back. They are the navigation lights at the end of the wings.
Yes.
That's the pitot heater.
Pitot.
The pitot heater looks like that. It's under the wing, and because it's stuck out under
This
the
one
wing,
here?
Yep, the air goes into it, but it can freeze up.
Yes.
So if you go into visible moisture, you'll turn the heater on it.
Yes.
To keep it from freezing up.
Yes.
And the air coming through that supplies these. These are air-based instruments. This
Yes.
uses air pressure.
Yes.
So the air needs to come in from the outside to get into this instrument.
Yes.
And that goes through these. There's another one called the static and the static source, and there's holes in the left and the right side of the fuselage, but there's also one in the aircraft as well in case that freezes up.
Yes.
And these are your that's your forward light and that's your landing light. So that's obviously more focused forward light, so air traffic can see you 20 miles away.
Yes.
And they're LEDs on this plane. We upgraded them. Flaps reduce your stalling speed at slow
Yes.
speeds. It allows you to fly more slowly without stalling, and you get a takeoff flap and you get a landing flap.
Is there a midpoint on that?
Yeah, there is a mid one, but we don't typically use it. We've got, I won't put it on, but there's a little red piece of tape that you can look over your left shoulder and go, the flap's in the right position for landing.
Yes.
Or takeoff.
Mhm.
So this is the alternator switch, and there's the power, battery, master. Carburetor heat we've discussed, throttle,
Yes.
and it is throttle because it's connected to a carburetor.
Yes.
Some other aircraft they call single lever, single power, where basically this is connected via a cable to the carburetor.
Yes.
Engines that have full digital engine management systems, all this does is control a potentiometer
Yes.
that just knows where you are, and it commands the engine computers control the power. So this becomes a power lever
Yes.
in percentage
Yes.
power, and you get a readout that goes 50%, 60%, 70%, and you'll take off maybe at 93%, so you'll put the power forward to 93. In this aircraft, it's a throttle because it's connected to the carburetor, so that is idle, that's max power.
Yes.
And in between, we're looking at the RPM,
Yeah.
which we can't see because it's on here, digital, and we'll go, okay, at this particular phase of flight, we're going to be 2300 RPM.
Yeah.
So we'll push that forward until we get to 2300 RPM. And
Yeah.
as you climb, that may drop because the oxygen levels change, and you might put just a dig more power in to get the 2300.
Okay.
So we're flying these type of airplanes using the RPM gauge
Yeah.
to get power. This is all this is doing is increasing or reducing the RPM.
Yeah.
Propeller. So the propeller's got a gearbox in it,
Yes.
and the gearbox at the moment, all propellers go round, but the blades will actually twist.
Yes.
So they will either cut more air or cut less air. And this is very coarse and this is very fine. And as you take off, you go full, and once you're in flight, you want to improve the efficiency of the aircraft, and you'll bring it back until
25-ish?
the end, no,
Or
it's
less? More?
We're looking for about 24. It's called 24 squared.
Yes.
It's not a real thing, it's just kind of an estimate.
Yes.
And in these planes, it's okay to estimate
Yes.
because you can't be perfect.
No.
And this is mixture, so that's fully rich and that's fully
Lean.
lean. Engine will stop there.
Yes. Okay.
So we go up so typically we could be flying around there, and we say, okay, we're at 3,000 feet, we're leveling off from the departing the airfield, and we'll pull this back to get the prop back, and then we will and we use the engine pressure to detect what position that is in, and we'll be looking for around 2400 RPM and 24 on this, and that'll be a number there at the top, and we try and get them balanced. So that might be there, and then what we do is we'll bring this back and we get the exhaust temperatures.
Yes.
And we'll bring this back. Now you don't need that. What I can do is I can listen to the engine and I can pull it back, and I hear the engine change tune.
Yeah.
And then I just put it did forward.
So with our throttle, so this is to keep our engine sounding in a pressured zone, or
it's getting the right fuel mixture into the cylinders.
Yeah.
Depending on the phase of flight.
Yeah.
If you're cruising along at 120 knots,
yeah,
you don't need to be full mixture.
No.
We can save fuel.
Yeah.
So what we do is the engine will go, and suddenly it will go slight different sound, and you'll go, right, I've just removed too much fuel.
Yeah. I'll just give it a little tick.
Give it a quarter of an inch.
Yeah.
And the engine will then return to normal, and therefore you're getting good combustion. So you just get to see the helicopter coming down. You might actually, because he's a big boy, you might actually be ground taxiing because he's got wheels.
Yeah.
A lot of helicopters don't have wheels.
No significant clouds. Temperature 8. Dew point 8. QNH 1020 hectopascals. QSE 1018 hectopascals. Airfield.